Hello, my name is Krupal. I am here to present our project, a chaos-based AES encryption system. This system is built on top of the existing AES algorithm using that dramatically chaotic double pendulum, which generates proper random chaos. But you may ask, why this system? Nowadays, data is a vital resource. Data theft and exploitation are the significant problems of currently digitalizing systems. Here, data security plays a vital role while storing data anywhere, whether it is cloud storage or a local system. If we talk about cloud storage like GCP or AWS, they may or may not encrypt your data depending on the SLA. We try to provide a way to encrypt your image or text data before storing it anywhere. To do this, currently we need to use AES algorithm. The the solution we propose works on top of the AES algorithm by modifying the key generation process of AES and making it more secure, robust, and randomized. We propose to use a double pendulum that is dramatically chaotic and acts like a random function for the key. The only possible way to replicate the exact same motion of the pendulum is to keep the value of its initial 8 parameters accurate, up to 8 digits after the decimal. This GIF shows the motion of multiple double pendulums having only slightest difference in the initial conditions. We can use this property of a double pendulum system to generate the chaos required to make the key, which can either be the master key or the round key, depending on the level of security required and the time to run. Generating round keys directly from chaos gives an added level of security compared to generating a master key from chaos, but it causes the processing time. The initial conditions of a double pendulum can be selected randomly, like the mass of bobs, length of the string, angular velocity, and angular displacement of masses, which will form the user key. This key will be downloaded directly into the user's computer to provide security while transit. These initial conditions will kick off a virtual simulation, double pendulum, which will be sampled for angular positions of bobs that are genuinely random and converted into binary. These binary sequences will be sampled many times in a simulation, and together they will form the master key or round key as per the level of security purchased by the user. These two levels of security can provide a solid business plan on a subscription basis to users who wish to keep their data safe and encrypted. Then, the general AES algorithm can be carried out. Uh, AES is itself secured, but we try to improve upon the security by drastically increasing the expected time to cryptanalysis or attack the system by using a double pendulum. A double pendulum can be used to replace the generic key generation process of the AES. We have built a demo workframe website to explore the functionality and correctness of the algorithm and use it as a product. Now I will take you through a demo of the system. Currently, the system offers four types of options to encrypt your data. Firstly, you can generate a new key and encrypt the text data into an image, or you can use the old key and encrypt the text data into an image. The above same options are also available for image encryption. A decryption port is also provided in the same system. Firstly, the system has to be generated by a token has to be generated to activate the system and prevent malicious users from attacking. This token allows users 2 minutes to complete the process, which is generally sufficient. Firstly, we will select our data and prompt asks us to select the data type. It is crucial to select the correct type of data. Firstly, let us try to select the data. A radio option asks the users to select if they want to use a previously generated key or generate a new one. If you let us select if you want to select a new key and pass the data, the system will generate a new key for you and download it into your computer. This key will be used to encrypt and decrypt the data to keep the key safe, as there is no copy of the key stored on the server. So there is no way going back in case the key is lost. New directory are created to store the encrypted images and keys by default, which can be renamed and relocated later by the user. The system takes time as the process is longer and the simulation has to be run. As you can see, this is the encrypted image. If you want to see, this is the encrypted image of the text which we have provided, and the output screen shows the relative path of the key file and encrypted image. In decryption, while decryption, you must upload the encryption image and the correct corresponding key to decrypt the data. Let us see the decryption process. The process might take time as it runs the same simulation with the initial conditions as mentioned in the key. If the key file is tampered with the slightest change in the key, can distort the original data by avalanche effect. The output window will show the decrypted text and the corresponding key file used. So as you can see, the decrypted text is here, while the corresponding key file used is given here. If you go through the image encryption now, as you can see, encrypt data image, it asks us to choose the file which we want to encrypt. Now let us try to use the old key which was already been generated by the text encryption. So we'll click on yes, I want to upload an existing key, submit. It now asks us to upload the key which was used or which one you want to use. I want to use this key, submit. The system we are using provides us an added benefits over AES like increased randomness, protection against site analytics, and high complexity of flipped analysis attack. The decryption process stays the same for the image. As you can see, the output screen shows the path of the encrypted image, the status, and the key file generated or used. This is the encrypted image of the image we have used earlier. Now to see the decryption process of the image, let us try and generate again it. Decrypt. The output window shows the path of the decrypted image and the status. We can go and see the decrypted image, which is exactly the same image without any distortion. You can also see that the keys are getting downloaded into the system of the users, and there are no copies stored on the database or in the server, which is a highly secured way to encrypt any file or which you can use the path. Thank you for viewing. This was a demo of our system.